It's on.
Okay, hello everyone, I'm Ethan Barnett, and today I'm going to show you my design for a automatic cat food dispenser for my cat named Tom, for my Tom. Okay, why an automatic cat food dispenser? It takes away the responsibility of having to feed my cat every day, which I've been forgetting, and cat food dispensers are pretty expensive on the internet. And Tom will no longer wake me up in the morning. He wants to be fed. So, those are my three reasons. Problem statement. Design a system that will automatically dispense food at requested times. So, I'm going to have it hooked up to a real time, hopefully, and be able to set times where it will dispense cat food. I want to be able to have push buttons that will change the amount of cat food that's dispensed into this bowl, and to have an LCD display to show what setting it's currently on, and to be small enough to fit in different locations in case I ever want to move it. My idea was to have a horizontal auger. It was going to be connected to the line voltage and use a 12-volt power adapter. It's going to have an LCD display to show the time and the amount of cat food that it's going to dispense. It's going to have push buttons to adjust the size of the serving, and it's going to have an LED to show when the cat chamber is low. This is my system diagram. There's going to be a 12-volt power adapter, which I mentioned. It's going to go into an LM7805 voltage regulator, which will drop the voltage from 12 to 5. That will split into the LCD and the micro, and that will go through a transistor, which will boost the current to give it enough power to run the motor, which will be hooked to the auger and dispensed into the bowl, which will feed the cat. Motor specifications. The rated voltage is 12, and the max current at max efficiency is 172 milliamps, which I will design the resistor to pretty much get around there so I can get max efficiency out of my motor. Motor continued. It's going to be connected to the auger at the very end, and it's a D-type shaft. So I designed that on Tinkercad, and it's pretty much just going to be connected right to the motor, and that's that. This is where I figured out how to design it. I looked at the D-type shaft and saw that I did the difference between these two and made it so it would fit the end of the auger. The LCD takes about 5 volts, and as I mentioned, I'm going to use a 7805 voltage regulator to step the voltage down, and that'll split between the micro and the LCD. LM7805 voltage regulator electrical characteristics. It says here, if you have input voltage of 8 to 21 volts, you'll get between 5.7 and 6.3 volts, so that's where I decided to use that one. This is basically the circuit that I'm going to use to run the motor. I decided to use a 2N3904 transistor. It has a beta of about 100. So I'm going to adjust, I didn't put it in this circuit, but I'm going to adjust the R value to get it to about 150 milliamps to be able to run the motor at pretty good efficiency. And that's that. The schematic. Here is where the 7805 will be connected to VEE, which is the 12-volt power adapter, and VCC is the 5-volt output. Here's the LEDs that will display when the cat food chamber is low. Here's the LCD circuit, and here's the push buttons that you can adjust the amount of cat food that's going to be dispensed. And that's that. And I didn't finish the routing, but this is kind of my idea. LEDs aren't going to be connected right onto the board. They're going to be off on the outside of the whole block, and then the user will be able to see when it is low and can refill the chamber. Here's my 3D prints. The auger you've seen, it's going to go right inside that cylinder, and the cat food is going to drop down through this funnel into the square on the top, and the auger will just push it out when the motor is turned on. And that's just to give you an idea of what it will look like when it's all together, except for the motor over here. And that's about it.
Can you go back to the slide entitled 2M394? So where is the 150 milliamps in that circuit?
Well, it'll be right here after it goes through the transistor. The resistor will, after you multiply the current output from the micro, or I guess it's not. R is calculated by Ohm's law, so it's the voltage, the 3.3 volts divided by the current that's being output, and that'll give you the resistance, and that'll give you the current that you need to run the motor.
Okay, so is it going to take 150 milliamps out of the micro?
No, it's going to, well, it's going to go through the transistor. That's where it's going to get its current.
Okay. Is there some reason why you didn't put a calculation there? Or what's stopping you right now from doing that calculation?
I did it. I just didn't put it in the slide.
Okay. So you have it. Did you put? Is that 100 ohms on R1?
Yeah, I didn't change it because I don't know exactly what I'm going to have. I want to test the motor and see what, just by preference, to see.
Okay. What is your calculation? Say, you remember offhand? Is it supposed to be?
It's probably 600 to like 800 ohms.
And then on the motor slide, this motor specification slide, I may have just missed it. What did you want them to know about the motor?
On this slide?
No, the other one, the first one. No, right there.
I was just showing the specifications to show that at max efficiency it takes 172 milliamps, and
Okay.
it requires 12 volts to run.
All right, so what's the speed of the auger? Is that irrelevant, or
I mean, the auger is going to turn as fast as the motor's.
what speed do you want the auger to? Wasn't that an important factor in choosing that motor?
Oh yeah, I mean the revolutions per minute. I didn't want it to just be flinging out cat food, so I wanted something between like 40 and 60 revolutions per minute.
Okay. And back on your second slide, Tom will no longer wake you up. Can't you just close your bedroom door?
No, they get underneath the door.
Is that it? They're like octopi, they just...
I don't know how they do it.
And I currently don't have a bedroom door.
There's a problem.
Yes, correct.
All right. Any questions?